guys, here's your review for your geometry test that you're taking tomorrow. Actually, you're taking on Wednesday. I'm going to upload this a little early so that you can see if you're having trouble. So, your review, I've done a few things already on here, but let's start at number 1. Number 1 says, a person at the top of a 120-foot lighthouse, so I'm drawing my lighthouse, and it's 120 feet tall. The person standing on top sees a boat below. So the person here, they see a boat that's below at an angle of depression of between the top of the lighthouse and the boat is 30 degrees. Remember, your angle of depression is on the outside. So this 30 degrees is out here, okay? How far is the person from the boat? So the person is up here. How far is the person from the boat? That's what we're looking for, okay? Do you remember? It's the big question. Angle of depression is on the outside. This horizontal dashed line and this line at the horizon, the horizontal line, they're parallel. So this angle right here is also the same as the one on the outside because of alternate interior angles are always congruent. So that 30 degrees is going to come inside the triangle at the bottom. Okay? Always going to be there. Now, if I'm trying to find what is this x, what do we have related to this 30 degrees inside my triangle? The opposite is 120. The hypotenuse is what we're looking for, right? So we're thinking of trig functions that are relating the opposite to the hypotenuse. What is that? Yeah, it's so sine of an angle, which we have as 30 degrees, equals opposite over hypotenuse. Can you solve for x? Of course you can. So we're going to switch places when it's in the denominator. Your x will equal 120 divided by sine 30. Okay? I'm going to go ahead and pull my calculator up because that's one thing I forgot to do. So you can just plug that in your calculator. I do want to make sure that everybody is in degree mode. Okay, so if you are in physics, my juniors, make sure your calculator is in degree mode. You know how to do this. Hopefully you've been able to change back and forth. But if you don't get the same answer that I do, then we need to check your calculator, okay? So if you have the TI-84s, it'll say at the top, just one second, we're going to close. It will say right here, degree. Okay, if you see that degree, you can stop. You don't have to worry about anything else. Okay, so I need to do, I can't do that. Let's go this direction. 120 divided by sine 30. And you should get 240, in this case it's feet, is our answer. Okay, sine 30 should be a half. Okay, if you don't get 0.5 when you do sine 30, something is messed up. Well, not something is messed up. You're not in the right mode. Okay, so there's a little button right beside the second button, and it says mode. Okay, the only thing that you need to go to, this button right here, degree and radian. I put it flashing on degree, and I hit enter, and then just hit quit. Second mode is quit. Okay, make sure you're in degree mode because there's more on here that you'll have to do. Okay, so your answer number 1 is 240 feet. Now, number 2, I drew this out for you in the diagram. Circle J is tangent to circle L, and KM is tangent to circle J. So what does that tell us? If this line is tangent, what does that tell us about this piece right here? The radius must be 90 degrees, okay? That's a theorem somewhere, okay? The radius of circle J is 8 meters, so we know J to K is 8 meters. We know J to this circle is 8 meters, okay? The radius of circle L is 6 meters. So here to here is 6, and here to here is 6, okay? Can you find the area of triangle JMK to the nearest square meter? So we're trying to find the area of a triangle, yes? Area of a triangle is 1/2 base times height. Okay? We are looking for right angle. So I need this 8. So I know 8. 1/2 of 8. Oh, what's the height? It's K to M. You have to find the third side of a right triangle. You know 2 sides of a right triangle. Can you find the third? Yes, you can. Well, I need to know J to M. That's my hypotenuse. So the hypotenuse equals, I think that's 20. Yes, 20 meters. So how can we find K to M? We're going to say 8 squared plus x squared equals 20 squared. Okay, now I'm going to simplify. X squared equals 20 squared, I believe is 400, minus 8 squared, which is 64. So what is the square root of 336? I don't know. I'm just going to plug it in my calculator. So my calculator says, what is the square root of 336? Because they've asked to the nearest something. So I'm definitely going to plug it in my calculator. Times 8 divided by 2. To the nearest square meter. So it's going to be approximately 73 meters squared. Okay? Because I'm rounding. Keep all those things in your calculator. Okay? All right, we're moving on. Number 3, I have up here a little bit. If triangle PQR has vertices at 2, 4. So I go over 2, up 4. That's P. Q is at 4, 2. And R is at 1, 1. Okay, so there's our original triangle. Graph the triangle and its rotation 180 degrees counterclockwise about the origin. Okay, so we're going about the origin and we're going 180 degrees. So I'm looking back in my book. Pull this formula out there. It's okay. I have to look back at it. Okay, I'm going to transform xy to go to negative x, negative y. Okay, they're just going to become opposites. So, if I have all my points there, R, well, so I like to start with R, but it doesn't matter. I'll start with P. So, P was 2, 4. So, we're going to transform 2, 4 to be negative 2, negative 4. That is P prime. We're going to transform 4, 2 to be negative 4, negative 2. That's Q prime. And last but not least, 1, 1 will become negative 1, negative 1, and that is R prime. So we're going negative 2, negative 4. That's P prime. Negative 4, negative 2, that's Q prime. And R prime is negative 1, negative 1. Okay? Does it appear to have just rotated? It has. They've all gone 180 degrees. They all should lie actually on the line with the origin in a straight line. So you should have the same slope from P to the origin as you did after the origin to P. So it's up 4 over 2, up 4 over 2. That's just a little way to check. Okay? Graph the triangle and its rotation. So it didn't necessarily ask for the coordinates, but it asked for the graph. Okay? Going on, number 4. Is the parallelogram below shown to be a rectangle? Number 4. Is it a rectangle? So it tells you it's a parallelogram. Every parallelogram, opposite sides are opposite angles. Well, opposite sides too. But opposite angles are, that's right, they are congruent. Okay? So I can set 10x plus 10 equal to 12x minus 6. Okay? Because it's a parallelogram, I can do that. So I'm going to subtract 10x from both sides. And I'm going to add 6 to both sides. Okay, if we were doing this in a proof, I wouldn't do this all in one step, but we're not. Do it, it's okay. 16 equals 2x. Divide by 2, x equals 8. When you plug x in, so 10 times 8 plus 10, what does that equal? That's 80 plus 10 is 90. It's 90 degrees. 12 times 8, which I believe is 96, and it's minus 6. So what's 96 minus 6? 90 degrees. Yes, it's a rectangle. Okay. I'd like to see your work. Tell me that you did that. Number 5, identify whether the figure below has a line of symmetry. Do this to the best of your ability. If you print your test out or if you do just put it on there, just draw it on your test. Don't try to recreate this little weird teardrop looking thing that's like this. Is there a line of symmetry? Yes, there is. Draw a line down the middle. Okay, you're done. I'm going to go ahead and do number 6. Here also. A few less pages to print. Identify the type of transformation illustrated below. I don't want you just to identify it. I want you to tell me about it. What is it? What happened? So, did it flip? No. What happened? Did it rotate? Yes. It's a rotation. Yeah, it went it went clockwise about point Z. Okay, tell me a little bit more about it. All right, number 7, which I probably needed the grid up here for. You never know where I'm going to be. Okay, so number 7 says, I'm going to have this thing too. This is going to take up a little bit more space than I'm probably prepared for. Alright, it says the equation of circle B is x squared plus y squared equals 64. So remember your equation of a circle. X squared plus y squared equals 64. Remember that is an r squared. We are centered at the origin, which is 0, 0. What is the radius? Radius equals 8. I'm going to run into all of that. Okay, so centered at the origin, and our radius is 8. So I'm going out 1, 2, 3, 4, 5, 6, 7, 8. Labels are key. 1, 2, 4, 5, 6, 7, 8. There's 8 there. 2, 3, 4, 5, 6, 7, 8. Here's negative 8. And then down. 1, 2, 3, 5, 6, 7, 8. Negative 8 there. And our circle should hit. I know your circles will look much better than my circle will. Okay? That's the graph of your circle. The biggest key is I need to see your points where it hits. Okay? Whatever the radius is. Okay? I'm going to go ahead and go to another page to do number 8. Number 8, there's a circle. There's a formula that says angle R, or whatever exterior angle, that's the big key. Theorem from lesson 79. Exterior angle equals 1/2 of the bigger arc minus the closer arc, which should be smaller. Okay, so 79 minus 23, I believe is 56. So what is half of 56? It is 28 degrees. Number 8 is 28 degrees. Number 9, just plug in your calculator, sine 72 degrees. That's why you have to be in degree mode. Okay, and it wants it to the nearest hundredth. So 2 decimal places. When I plugged it in mine, I got 0.95. That is not a degree. You are not getting a degree out. It's just a number. 0.95. Okay? Moving on, number 10. Oops. Wipe something off my board, put a mark there. Number 10 is asking for that angle again, angle EFG, so really angle F. Go back to lesson 64 theorems, okay? When you're looking for an angle that's actually on the circle, angle EFG will equal 1/2 of its intercepted arc. So it's half of 158. What's half of 158, you say? It is 79 degrees. Okay? Flipping my paper over. I'm going to try to do number 11 on this side. Just save paper because I will print all these. Number 11. Walter is tiling a patio that's in the shape of a regular hexagon with 16-foot side lengths. What is the total area that must be tiled? So we're going to a regular hexagon. Okay? Hexagons are special. Why are hexagons special? If they're regular, then they are all congruent, equilateral triangles inside. And if all of these are 16 feet all the way around, okay, and I just told you that these were congruent equilateral triangles. There is something special about them, okay? All the sides are 16, all the angles are 60 degrees, okay? So how can I find the area of one of these triangles? What do we do with isosceles triangles? We cut it down the middle, make it a right triangle, divide the base in half, divide the angle in half. So now I'm going to pull out 1, 30, 60, 90 triangle with a hypotenuse of 16 and a short leg of 8. That's half of the hypotenuse. What's the height? Some of you have it. Some of you are going to have to do the Pythagorean theorem. We need to get it. It's 1, 2, and then square root of 3. It's the short side times root 3. Okay? So green triangle. Can you find the area of this green triangle? So I'm going to write area of one triangle. Okay, what's the formula for area of a triangle again? 1/2 base times height. So my whole base is 16. So it is 1/2 of 16 times 8 root 3. That's my height. This is 8 root 3, which is right here. Okay, so I'm going to go ahead and take half of 16, which I know is 8. So one triangle is 64 root 3. That's one green triangle. I know there's another formula, but I always forget it. This is what I know I can do. Okay? So, what's the area of 6 of those triangles? Because remember, there are 5 more of these triangles. So if I know the area of 1, can I find the area of 6? Yes. So I'm just going to multiply 64 times 6, and I'm going to get 384 root 3 feet squared, right? Yes. Or if you plug that in your calculator with the square root of 3, it's approximately 665.1 feet squared. Okay? My answers have the square root of 3, but I will take either one because they don't specify. Okay? All right, we're going quick, but we're going to keep going, so this is not crazy long. Number 12. And if you have not gotten your little book, your lateral area, surface area, volumes of, if you do not have that with you, stop right now and find all of those areas. I'm going to see if I can find the lessons. I know 80, I'm pretty sure 59, Yeah, I don't have the book that I wrote all the lesson numbers down on. I've got a different one here. Okay, but you need to go find those. Prisms, you really have to have cylinders, cones, pyramids, and spheres in this one. I know one of them is lesson 80, one of them is 72 or 74 or 76, I don't know. But you need those. Find them, write them down on a piece of paper. You have to have them. All right, starting with number 12. Here we go. Calculate the lateral area of a right cone with a radius of 3 and a slant height of 9 to the nearest square inch. So if you have your little book, you turn right to the formula for cones, and it says L equals pi r L. Okay? And it says to the nearest square inch. So we're going to plug in pi times the radius is 3 and the slant height is 9. So 27 pi, and if you have not, please use the pi button. Your answers will be different than mine, and I'm likely to count points off. Okay? So I'm going to hit 9 times 3, which I'm pretty sure is 27, but I'm going to do it just in case, times pi button. Okay, 84.82 round to the nearest hundredth. So it's approximately 84.82 inches squared. Okay, use the pi button. Just do it. Number 13, the vertices of a triangle. I need a graph, so I'm going to go to another page. But I really don't have to, do I? It doesn't move that much. I'm just going to put it on this one. I'm sorry. Because I can. And it's not going to be that big of a deal. It's only really in these other quadrants. I'm probably going to move this one up one. Okay, that didn't change a lot, but it's going to help me out just a little. A is negative 1, 0. So here we go. A is negative 1, 0. B is negative 3, negative 3. And C is 2, negative 2. So there's my original triangle. Find the image of triangle EFG after the translation, which they didn't mean EFG. It's a prime of this translation. Show the pre-image and image on the same coordinate grid. So I'm doing number 13, and they want me to transform XY to X plus 2. Means I'm going all of them moving right 2, and Y plus 4, which they're going up 4. So this means right 2, up 4. Okay, that's all that means. So here we go. A, I'm going over 1, 2, and up 4. 1, 2, 3, 4. So there's my A prime. Okay. C, just because I'm over here, it's 2, negative 2. I'm going up 2, and, right 2 and up 4. That's why I wrote that out there, so I wouldn't forget. So B, right 2, up 4. 1, 2, 3, 4. B prime. Does not matter what order you do them in. Just do it right there. Show the pre-image and image on the same coordinate grid. You're done. They don't ask for the coordinates. You could find them if they asked you to, but they didn't ask for it. All right, number 14. The volume of a tetrahedron. If you didn't know what a tetrahedron was, guess what? They're going to tell you. It is a regular triangular pyramid. So you have to get that little book and look for pyramids. Okay? We want to find the volume, where the base area is 7.2 square centimeters and a height of 4.38. So I'm going to look for the volume of a pyramid. It is 1/3 big B times H. Okay? What does the big B stand for? the area, and scroll behind, the area of the base. Guess what they told you? The base area is 7.2. You don't even have to calculate anything. All you have to do is multiply. So you just multiply these two numbers and divide by 3. And you're done. Number 14 should simply be, is approximately 10.44 centimeters cubed, because it's a volume. Okay. Number 15. Find the lengths of the sides of a kite, STUV, shown below. Round to the nearest 10th. So there's a kite, and we learned something about kites. Consecutive sides are congruent. Adjacent sides are congruent. Okay? So then you also know something else. I think we talked about that their diagonals are perpendicular. So when this is 2, and this is 3, and this is 4, can you find S to T? And if you can find S to T, then you know S to B also. Pythagorean theorem. You've got two sides of a right triangle. So 2 squared plus 3 squared equals ST squared. So 4 plus 9, I'm sure it's 13. So the square root of 13 is S to T. Do they want square roots? No, they asked for the nearest 10th. Please read the instructions. And ST equals S to V, and they're both approximately 3.6. Ooh, extra little line there. Okay, so that gives me these up here. 3.6. What about T to U and V to U? Yep, I'm going to do the Pythagorean theorem again. So here we go. I'm going to change colors. So we know 2 squared plus 4 squared equals T to U squared. So 2 squared is 4, 4 squared is 16, equals TU squared. This is 20. So the square root of 20 is T to U and V to U. And that's approximately 4.5. Okay? Plug them in your calculator because it told you so. All right, 16. Find the surface area. We're pulling out our little book again. 16. That's a 16. Find the surface area of a sphere. So S equals, I'm going to the one we just did in lesson 80, of a sphere. Radius is 6, so S equals 4 pi r squared. And if the radius is 6, oh wait, and they tell us in terms of pi. So I'm just going to leave the pi out there and not plug anything in. So 6 times 6 is 36. 36 times 4. 36 times 4 is 144. And then we're just leaving pi, and it is inches. Yeah, it was inches squared because it's surface area. Okay. Number 17. Lateral area of a cylinder. It's your little book again. Lateral area of a cylinder with a radius of 3 feet and a height of 11. So I'm looking back at my lateral area of a cylinder, and it's 2 pi r h. And leave in terms of pi. So I have 2 times pi times 3 times 11. Leaving pi, I've got 33 times 2, 66 pi, and it was feet squared. Okay. 18 we've already done. It was the handshakes. If you did not watch that video, the answer was 36. It was 8 plus 7 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1. I would suggest you go back and watch that video. It's separate. I'll attach it when I put these copies in there. All right, last two. Here we go. Number 19. I have to have my grid again. I'm sorry. And it's mostly above. Okay, so there's a rectangle. EFGH has vertices at -2. This is number 18. -2, 8. 1, 2, 3, 4, 5, 6, 7, 8. So there's E, and 4, 8. That is letter F. G is 4, 6. And H is -2, 6. So here's my rectangle that we are going to reflect across the line y equals 4. Where is the line y equals 4? It has a y-intercept, yes? Of 4. Y equals 4 does not have, it has a slope of 0, right? So if we were to write into y equals 0x plus 4. Y-intercept is 4, slope is 0. It means we're not rising, we're rising 0, but we're running forever. Okay? So we want to reflect this rectangle across the line y equals 4. I go with the ones that are closest to it, so I would move letter H or letter G first, either way. Okay, it's 2 units above, so I'm going to go 2 units below. That is my H prime. Okay? And it asks for the coordinates, so we'll do that in just a second. I'm not going to do these little loopity-loops anymore, really. G has to be on that same line. It was 2 units above, it's going to be 2 units below. E is 4 units above, so it will be 4 units below. Okay, and F prime will also be 4 units below on the same line. Okay, so we've reflected it. Now we need coordinates. Now F is 4, 0, G is 4, 2, E is -2, 0, and H is -2, 2. Okay? That is your number. No, that's number 19. Why did I say 18? Because I didn't do 18 officially. I did it earlier. That is number 19. I apologize. We're graphing, we're reflecting, and we're done. Okay, I'm going to do number 20 on this same page. I'm going to erase this little piece right here so I can do number 20 over here because I need to graph again. It says add the equal vectors S, T, and U shown below. So they just put vectors up there and they don't really tell you much about them. Okay? They have a starting point or an initial point here. This is vector S, and they tell you they're all the same. It has a terminal point there. What do we know about all vectors? I'm going to put the initial point at 0, 0. Okay? And the terminal point, if we wanted to find the components, which is these little things right here with the alligator marks, I go over the x value, 1, 2, 3, 4, 5 is my x value. 1, 2 is my y value. Okay? And if I wanted to add them together, how many are there? S, T, and U. I can simply multiply times 3. Or we could add 5, 2 plus 5, 2 plus 5, 2. When you're adding things 3 times, you can just multiply by 3. So 5 times 3 is 15. 2 times 3 is 6. So your answer, the components, if we put them all back to back, would be 15, 6. All right. I hope you've stayed on. Hope you've got it. I love you guys. This is the last video that I'm doing, and I'm kind of sad. But we'll be together again soon. Bye.